Good. Start again. Good morning and welcome to Science 9 in the AM. This is Team Gary coming to you live and recorded. Our students have jotted down completing a circuit study question. They created a purpose, listed the materials, and right now they're trying to light up this bulb. I'll pause the video and let you jot that down if you're on record. Okay. So, hey guys, thanks. I'm just going to go over what Cameron is frozen. Just going to go over what Cameron has. So right now, we have, and I've seen this multiple times, this is usually the first way people do it. The tip of the ball, right there, to the, which end is that, the plus or the minus, the positive or the negative? The wire is on the side of the battery and wrapped around to the bottom, the negative end of the battery. Huh. Now, so far so good. I'm going to just get rid of that pen. And do you want the battery right set up, or do you want, how do you want this next one? The bulb upside down, or? Oh, well then, thank you. Maybe I won't. Connie, did you have more than one line? You're going to be a teacher. You should come up here and try this. Oh, goodness. I just don't feel like working. Hey, Trey, you guys have 4 ways. Get up here. Well, technically, I'm going to get you up here. God, both of you. You got teaching in your blood, too, Trey. What? You got teaching in your blood. Okay. Oh, yeah. 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 Okay. What you need to do is just grab this, and okay. Now, that's what, how do you want it? It's upside down. Okay. So press that once, tap it, and then, yeah. You know, it's very intuitive. Okay, then now. Okay, do you want, was it touching or not? Yes. Yeah. So maybe make that touch. Okay. To do a wire, just press this and okay, there we go. Okay, the second way, and I can just leave this for a minute and talk about it. Guys, this way. Okay. So this is a good way, right? This worked. I saw this. Usually that is the second way. Now, I'm going to ask you a little bit about this drawing here on the board. Is this continuous metal right there on the light bulb? Like, take a look at it. No, really look at it. Is there a separation between the metal at the tip and the metal on the screw-in part of the side? Is there a separation, or is it continuous metal? So what do you see? Is it the same metal? I don't think so either, because colorblind, I can sure tell that there's a black zone around the tip, right? It's not the same chunk of metal. I'm just pointing this out because there's 4 different ways, 2 ways that are intuitive, but what I'm saying is, I'm going to just do a rough sketch and you don't have to come up, but just so you know our title. So if this is the base, that's metal. I should have drawn it. Then, do you notice that this piece of metal at the tip is not connected to this? It's not one continuous piece of metal. So that means that this is being connected here. And this piece of metal is connected here. The wire and the light bulb are touching 2 different parts of I'm saying the light bulb tip and the battery are touching, and a different part of the light bulb, the side, is touching. the wire in both of those examples, right? We found out it doesn't matter for this application whether the negative end or the positive end is touching the ball. Right? You guys agree with that so far? So we've basically given two different options for the battery. How could we get two different options for the light bulb? We can have the battery right side up, upside down. But can we do the light bulb in contact with the battery with a different part? The wire in contact with the light bulb, different part. That's what I'm asking. Did anyone have a variation that was different, basically different than the light bulb straight up and down? Did somebody have that? Then, or do we have work to do? I think we have work to do. I'm going to pause the recording while you guys figure this out. Okay, thank you, Peyton. Peyton just drew up two other alternate ways. The side of the bulb in contact with the positive end or the negative end of the battery. Now, there's something that's in common with all of these, and I'm going to explain a little bit. I'm going to be quiet and let you guys jot this down. This is sort of these are your observations. Pictures worth 1,000 words. Well, these pictures are actually worth 300 words. But I want you to jot these down. These are your results that I saw, not just with Peyton's group, but with us. And then we're going to see and look inside and see why this works. So what I want you to do is actually, maybe I'll turn on the light again. But when you're old, you can't see things as well. I just started wearing glasses the other year. Okay. Look at the light bulb. This light bulb is just glowing here, right? There's no parts inside it. But look at the light bulb. There is things inside, right? What do you guys see in the middle? They don't sell too many light bulbs. Okay, there's two little things sticking up, right? And then really light inside in between it. What do you notice? Okay, I'm sticking at the top. You see a really tiny thin wire? A metal. Yeah. Which is the part that glows? You're connected. So, first. Okay, so this, what I have blue across it, is what glows, right? Now, we can't see the rest of the parts, but here's what we're going to make some assumptions. Mainly because I'm telling you. This might connect to this. Then this, I'm going to draw it in a different color. Do you guys see what I just did there? Okay. What I'm doing is the tip of the bulb, I'm exaggerating the green tip of the bulb. Right? And it's a different chunk of metal than the base of the bulb, which I have with a little red dot. Well, we're going to draw it inside of it. But yes, we are going to draw this, but I made this a little larger. So what I'm saying is that you can think of this chunk of metal, the base, the screw-in part of the base, must connect to one of these, then goes across, connects to the tip of the bulb. Because there's a reason why those two pieces of metal are connected. Now, it makes a circle or a loop once it's connected to that. So what I want to think about is, this is called the negative end of the battery, right? Maybe we're going to imagine that there's electrons zipping through. Those are the negative parts, right? They're movable. The positives are not movable, right? We've learned this from static. So let's say that negative electrons come out, right? They go through the wire in this drawing. I'm going to add this in. They must go through, which color would show? Okay. So they come through the wire, go through this, across that, into the base, connect to the positive. What I have in blue is the inner workings of the light, right? And these light bulbs that aren't used in houses much anymore are easier to understand than an LED stuff. The principles of an electrical circuit, a loop circuit, are easier to understand with an old, they're called incandescent bulbs. So what I want you to add into each one of your diagrams is that thing that completes the loop. So I'm going to go with the negative case. Okay? You can add that in. Now I'm going to erase that sketch of a bulb that we observed. Then we've still got to come up with a conclusion. There's a reason we did it. Now, you can add that into the other two sideways bulb pins. I'm just going to leave it. I've got to think this through. We have enough information to figure out, come up with a conclusion. And that's the whole reason why we're doing this, to answer a question, phrased in the form of a purpose. So I'm adding the parts of the light bulb, the circuit. Here. Okay. What I wanted to emphasize, and if you haven't already, add this into your map. Every bulb actually has some inner wiring, right? So, what I want you to realize that the electrons have to have a path, and it has to be a circle to work. We're going to come up with the requirements, but let's think this through. This is more or less the minimum that you would need to light up this bulb. These three things. I could have given 2 wires, it's a little easier. I could have given 5 batteries. We're going to eventually learn how to wire up 3 bulbs in 2 different ways. 17. No. We'll probably just start with 2, something like that. We'll figure something out. But let's not get ahead of ourselves. Let's just see if we understand one bulb first. Because what we're trying to come up with is, what are the requirements to light a bulb with a battery? Well, we do need a wire too. Anyways. But we tried different ways that didn't work. And it took about 7 or 8 months this year for somebody to come up with a way. You know, there's a lot of ways that don't work. These 4 things have something in common. These 4 ways. I'm going to use, and when you study, if you're an electrician though, it really is arbitrary. It doesn't matter. If you think of it as positive current, like the energy coming out of the positive end, and you follow it this way. But we're in science and we're thinking about the parts that move, the negatives. So either way, it works. So if you're an electrician, or I do electrical work in my home, I actually think that it's positive. I'm thinking in science that electrons, this battery is just, something's going on in there. There's a chemical reaction. It's giving away electrons that have energy. And they leave the battery. They travel this. They go through here, and there's a special piece of metal there. It's called tungsten. That glows when it gets warm, and then goes back and returns to the battery. Right? Now, the same thing here, but the trip is just the opposite direction. Do you need me right away? Okay. We got that same loop. Thank you, Matt. I didn't. Yeah. The you guys get it? If we're sideways, it's the same thing. They all have a complete circuit, a complete loop, right? So what do we need to make a circuit work? A battery, an energy source of some kind, because it could be a plug-in electricity. I told you I'm not doing that for safety. Or some kind of battery, some kind of energy source. Good. One. Two.
A wire.
And the wire allows us to, we'll say a wire, but the wire alone doesn't do this, right? Because I know some people started out and just had the light bulb here. Most people started. It didn't work, did it? Why not? Because it wasn't in a complete circle, in a loop, or a circuit. Okay? And then you have to have something to, but how about this? I saw some people, try this. Complete loop, touches this. Looks like that. It didn't work, did it? That had a loop, had an energy source. It has to be a loop that includes this, right? That loop really is the same as touching your fingers as touching. That it has to be something that uses the energy within the loop, right? Does that make sense? For this circuit to work. Otherwise, it's just electrons going round and round and round. Oh, right. With this, you can see how my magic pen works. Once you make a circle, it has. By the way, if I make it a square, it makes it large. Okay? Anyway, so sometimes I inadvertently magnify things or highlight. Okay. So conclusion. The requirements are. I think we've heard them. So let's get them down as a group. Energy source. We mentioned this. Something to use the energy. Example of bulb in this case. Something to make a complete loop, the copper wire. Yeah.
If you were like,
So jot this down while Shane is mentioning.
this is really like a good one. Like if you were like clocking bombs, you break the bulbs like for the fire.
This one wouldn't create enough energy to start a fire, but in theory, if you had a large enough energy source and bulb system, you could, yeah. But that I don't believe would happen. The other thing is that these bulbs are airtight inside. The minute, if you ever crack a light bulb, one of these old ones, they burn out immediately. So they usually flare up a little, but a very little. I think it would be very hard to create a fire, but in theory, yes, you could if you had something really flammable inside. So they don't want air, because what's in air that burns? Yeah? Read it out. What are the gases? Carbon dioxide, but that doesn't burn. We actually just saw a video the other day of a carbon dioxide fire extinguisher. Yeah. Yes, the oxygen that we want to prevent from coming in contact with the glowing wire. So, as soon as that happens, it just melts away, burns away. Okay. So you guys are doing this, and then I have something underneath that too. So as far as our recording, we've got our conclusion that we brainstormed. Need an energy source, example, the battery, something to use it, the bulb, and something to make the complete loop. It has to be a circle, so the electrons could travel in a circle. What I'm giving marks for following that, though, is two non-examples, but you have to tell me why they don't.